Hello. So let us do this review of unit test. Please, for the test, do not forget your last name, first name, and the period. I'm starting to take off points for that. So the first question, we're going to work on two functions, one exponential and one logarithmic function. The first part A, is to graph the dotted line y equals x. It is just the perfect diagonal across the coordinate plane, y equals x. The part B is to evaluate a series of values. So for f of -4, what I'm going to do is to first store -4, the store button is right here, into x. Press enter, and then I'm going to type the function f of x, 4 exponent x plus 4, then I press the right arrow to exit the exponent, -3. I press enter, and I've got -2. I'm going to do the same thing for f of -3. I'm going to store -3 into x, and then I'm going to scroll up to recall the same formula. Press enter and press enter again, and I've got 1. I'm going to do the same thing for g of 1. I'm going to first store 1 into x, and then I'm going to type the formula for g of x. To have access to a logarithm base 4, you have to type alpha window 5. So I would have logarithm base 4, right arrow, of x plus 3. I exit the logarithm with the right arrow, -4. And I've got -3. And finally, I'm going to store -2 into x. I'm going to scroll up to recall the same formula for g of x. And I press enter. I've got -4. That's all there is to it. Now, what are the domain df and range rf of f? Well, f of x is an exponential function, so automatically the domain would be all real numbers. The range will start at k, sorry, which is -3. So it starts at -3 excluded towards infinity. And the asymptote will be y equals k. In that case, y equals -3. Let's do the first part of E and graph this function. First, graph this as a dotted line, -3. I'm going to use different colors. So -3 is here. I'm going to have a dotted line right here. And you were asked for part for B to graph those. So I have -4, -2, -4, -2 right here, and I'll have -3, 1, -3, 1. That is enough. you can eventually help yourself with the graphing calculator to sketch a decent exponential, which will shoot out like this. Now, for d, I'm going to do the same thing for the function g. The range of a logarithmic function will always be all real numbers. The domain of g, on the other hand, will start at h. And h, so remember the formula, it's x minus h inside, right? So because I've got positive 3, it's going to be negative 3. It's going to shoot up towards infinity. As you may notice, all the x and y coordinates are switched, swapped, exchanged, which would be important to notice for question F. And the asymptote will be not a y equal horizontal line, but a x equal, a vertical line starting at negative 3. So let's graph this asymptote at x equals negative 3. Let's graph those two numbers, 1, negative 3, 1, negative 3, and negative 2, negative 4, negative 2, negative 4. And that should be enough for me to sketch a decent graph of that. And as you can see, both graphs are reflecting across the line y equals x. They are inverse. So if you compose those two functions, f circle g of x, I should at the end find just x. So f of g of x, which would be f of g of x is logarithm base 4 of x plus 3, logarithm base 4 of x plus 3, minus 4. Then I'm going to shift my focus to f of x. F of x is exponential base 4 of x. And I think of x plus 4 and minus 3 outside. So instead of the x right here, I'm going to put g of x and have logarithm base 4 of x plus 3 minus 4. And the for the next line, I can notice that plus 4 and negative 4 cancel. I am left with 4 exponent logarithm base 4 of x plus 3 and minus 3 outside. Now, the exponential base 4 and the logarithm base 4 are inverse operation. They will cancel each other, which means that the x plus 3 will, so to say, drop. And I still have my minus 3 here, and 3 minus 3 is 0. I am left with x, and as you can see, they are indeed inverse.